expression I've seen in a while, actually. All right. If it were me, the first thing I would do is use log law number 2. Okay? Because I'm seeing a huge ugly fraction, but I don't need a fraction if I have logarithms. I can rewrite this as log base 1/2 of 4 cube root of x squared. And then what do I write? Minus log of, what should I write? Yeah, I could do that. If I write y z to the 1/2 power, does that make sense to you guys? Why would I want to do that? Yeah. And I'm thinking ahead. You know what log law I'm going to be using? The third log law, right? I love that. The most powerful one, since I'll be able to take that 1/2 out front. Now, I can't do it yet. I'm going to have to use another log law at the beginning here. So watch what I'm going to do. I'm going to write, let's see if this makes sense to you guys. And I guess I just have to keep putting in those 1/2s eventually. So let's see. Log, you know what I'm going to write? That's right, the log of 4 plus the log of, nice, x to the 2/3 power. By the way, these parentheses, I'm not sure we necessarily need them. Some people, for instance, would just write this next. Minus the log of y. Okay, now if you say plus, then I'm going to be careful because you guys have to understand, right? I'm subtracting this logarithm, so I'm subtracting, well, the log of y plus the log of z to the 1/2, right? I'm subtracting that sum because all that came from the denominator. So some people would write this step in pink, but some people would just jump ahead to this. I'll write this next. Log base 1/2 of 4 plus log base 1/2 of x to the 2/3 minus log base 1/2 of y and minus log base 1/2 of z to the 1/2. I think I would just write this and skip the step above it in pink. All I'm doing is distributing the negative. You guys follow me? So let me see, how am I going to do this? I think what I'm going to write next is, I'm going to call this thing big Q. This piece here. I'll figure out what Q is in a second. Plus 2/3 the log of x minus the log of y. Notice we don't even say the base when we say these things. And then minus what? Yep. 1/2 the log of z. Okay. I still have to figure out what that Q is, and then I'll be all done. So I'll do that work maybe below. Let's see. I know that the log base 1/2 of 4 is equal to Q. This one's a hard one. So how do I rewrite that? 1/2 to the Q equals 4. That is hard. That's one of the reasons I wanted to do this example, because of the base. This is not easy. Let me show you a trick. When I do the trick, you guys will probably get this. Okay? 2/1 to the negative Q equals 4. First of all, does that trick make sense? No. What do negative exponents mean? Take the reciprocal. You guys know that, right? Like what's 3 to the negative 1 power? What does that mean? It means 1/3. Positive though, right? So, yeah, that's a trick. And actually, Barb, I'm glad you asked that because that's going to happen tonight on the homework. You're going to be like, how do they get from there to there? And then we'll go over whatever tricks need to be filled in. I anticipate a few of them, and that's one of the ones I showed you. But some of it is you just got to try it. All right? And with experience, you'll think of things like I just did. You guys got this now? If 2 to the negative q is on this side, how am I going to rewrite 4? 2 to the second, right? Because what's the goal again, guys? We want to get the same what? Get the same base. And this is where Barb was saying, she didn't know how to get the base to be 1/2, and I didn't either. But with my trick, I can get the same base. I can get them both to have a base of 2. And now, coming over here, let's see. So what do I do next? I would do, well, negative q is equal to 2. So q equals what? Negative 2. So the final answer to this whole thing, I guess I could put it right in here. It's negative 2 plus everything else I had. 2/3 log of x minus the log of y minus 1/2 the log of z. Cool. The log laws. Now, again, these work for any base. It doesn't really matter what base you use. Okay? So what I'm going to do is I'm going to kind of generalize the first one here, right? We know when we multiply exponential functions, what do? We add the exponents, right? And so now I'm going to talk about what happens if I take the natural log of some product. Okay? So I'll write down, say, or the log of a product. So let me go ahead and write m times n. Okay? Well, again, the base is the same. When we multiply numbers that have the same base, for example, if I take x to the 5th times x to the 7th, I get x to the 12, right? So how did you do it? Well, what you did was we add the exponents. What about the base? The base stays the same. Okay, the base is going to stay the same in the log laws too. The log of m times n is going to be the log of m plus the log of n. The log of m plus the log of n. That's the first log law. Okay. Second log law, you'll probably know what to do as soon as I write the first part. Log of, say you have a quotient, m divided by n. I bet you know what to do. That's right. We're going to subtract. I mean, some people even think of these as being the same rule, because when you divide, you're multiplying by the reciprocal, and so it makes sense you would subtract. And again, my parallel rule for exponents, what if I have x to the 5th over x to the 7th? That means divide, right? So what do I write? X to the what? That's one way to do it, right? X to the negative 2, which of course means what? 1 over x squared. So you can get it by canceling, but you can also get it by subtracting the exponents, right? Well, same thing here. When we have a log of a quotient, we're going to subtract the logarithms. Okay, so those are the first two log laws. There's 3 altogether. The last one is perhaps the most powerful. I just like saying that. I don't know. It is. Okay? Suppose I have the log of something raised to a power. I'll call the power p. M to the p power. Okay? What would this be? You might be able to figure out what it's going to be. All right? Let me do an example down below here. Let's suppose I'm going to take, this is actually number 7 from your book, and then we'll come back to what that log law is. Number 7 from your book says we want to do the log base square root of 2. That's an awful base. By the way, these are all from page 445. This is section 2. The log base square root of 2 of 4x cubed. Okay? Well, the first thing I'm going to do is use which log law? First, second, or third? Well, we can't use the third because we don't know it yet. We're going to use the first. That's right. So what am I going to write? Well, the log of 4 plus the log of x cubed. And these are both base square root of 2. Okay? Now, I need to evaluate this, right? Now, I'll do that in a minute. What I want to show you is the long way to do this problem, this piece of it. So this piece of it, let me get out a green marker. And let me just point out that this piece can be rewritten log square root of 2. Isn't this x times x times x? Right? So, if I wanted to, I could rewrite this green logarithm as what? Yep, log of x, base radical 2, of course, plus log of x plus log of x. The log law says if you have a product, you could do this. Okay? So I have to figure out whatever this rectangle is, and then add it to what? Well, it's all those greens, right? You guys with me? No. You know why? This is like completely foreign language. It's kind of scary. You got these logs all over the place. And I don't really know what they are. Well, I kind of know what they are. They're inverses. Inverses of what? The answer is going to be rectangle plus 3 of these logs, whatever they are. Does that make sense to people? 3 of the logs. Okay, rectangle plus 3 of the logs. Now, I want you to understand there was a quicker way to do it. And it's the most powerful of the log laws. basically, you see that exponent, 3? You know what I do? Cool. That's the most powerful log law. The fact that when you have logarithms in your expression or your equation, you can take an exponent and bring it out front. Now, the green here kind of shows you why you ought to be able to do that if you have an integer exponent. Quick question, do you think it's going to work for fraction exponents? You're right, it will. Do you think it's going to work for any kind of exponent? You're right, it will. Okay? It will. So that's beautiful. Ooh, any exponent? Let me think for a minute. Yeah, any exponent. Okay. So that means let me write the third log law, and then we'll have them all in our notebook. What is the log of m to the p power? It is p log of m. And so, armed with these laws, I am ready to tackle the rest of the chapter. Well, at least the next section. Okay? I'm ready to tackle the homework. I'm ready to tackle number 7. Okay? And so, what I'm saying is if you were going to do number 7, when you saw this piece right here, you wouldn't do all this green, you would just jump right to there. 3 log of x. Okay? Now, one other thing they want me to do is that we can evaluate this. I don't know if any of you have done that yet. Right? How do you do this? You set it equal to y or x or something. Y equals log base square root of 2 of 4, right? Although I guess I've been doing it not on this side, I've been putting it on this side, equals y. Okay? And then what's the next step? What do I write next? The equivalent exponential function. So what would I write? Very good. Radical 2 to the y power equals 4. And now the hardest part, you have to figure out what y equals. And what I suggest doing at this point is you want to get the same what? Base. That's right. In other words, for this problem, I would rather write square root of 2 to the y equals square root of 2, well, to some power, and the whole trick is, can you figure out what power should go here so that it's the same as 4? I'm going to give you guys 20 seconds to talk to your neighbor about that and laugh at him when they can't get it. I like the reasoning I'm hearing. What happens if you square the square root of 2, you get 2? But we're trying to get 4, so we'd need another of those. So if I raise it to the 4th power, it works, right? So this y is 4. But remember, y was this thing in the box I'm trying to evaluate. And so it's just 4. So the final answer to problem 7, if you check the answer key, should be this. 4 plus 3 log of x, where the base is square root of 2. Pretty nice. Okay. We're going to use the change of base formulas. I mentioned these aren't very commonly used, other than maybe for calculators. Okay. So, anyways, the log base a of x. You can change a base to another base. For this one, I don't have to. By the way, for this one, what is the base? The base automatically, if you don't see anything written, remember, is 10. Okay? So if we want to evaluate it, remember what we do. We set it equal to something like q. And then we say what? Rewrite it as. So we're going to rewrite the equation. How? 10 to the q equals 1 million. And now, 10 to the q is the same as, what is a million? 10 to the what? 6th, and so q equals 6. And I'll be honest with you, I mentioned to you guys, my father, when he learned this stuff, he had a slide rule, right? And they use logarithms all the time, so I'm sure he, and probably you guys after a little practice, you're going to look at that and you're going to say, oh, that's 6. Because it's 10 to what power is a million? It's just a matter of getting used to the idea of this is the inverse of exponents. Okay? What exponent would make a million if my base is 10? All right, that's easy. Now, what if I said something like this? Find the log base 2 of 1 million. Well, now you get, if you go through the same calculation, you get 2 to the q is a million. And remember how Barb was stuck when we had 1/2 as our base? Now I'm stuck. I don't know what to do here. I have 2 as my base and I don't like it. So I'd be like, huh? Okay, so instead what I'll do is I'll use the change of base formula. The log base 2 of, let me just write 10 to the 6th, just for kicks, because that'll shorten it, scientific notation, is going to be equal to a ratio, and I'm getting this again from this change of base formula. What base do you think I want to change to? 10, right. So we'll write it as the log base 10 of something over the log base 10 of something. I guess I just have to know what goes where. Well, what goes where? The log base 10 of what? X. So what goes up here? Yep, the million. Over the log of what? 2. Now, to evaluate these, this is easy. What's that equal? 6. This is ugly. I don't want to do it. So my answer is 6 over the log of 2. Okay? But with a calculator, that's something I can do. Right? Basically, my calculator only has 2 bases on it. Okay? What bases do I have? Well, I have base 10, right? So the log of, say, 10 to the 6th, that's 6, like I said. But the log of 2, I don't have an exact value, but it'll give me a decimal. So I can do 6 divided by the log of 2 for some application if I need it. Okay? So it'd be about a little less than 20. All right.
Log base 2 of x plus log base 4 of x.
Okay. Log base 2 of x plus log base 4 of x. That stinks because now I can't combine with the log laws unless I have the same what? The same base. Well, that's a pain. I think the first thing I'm going to try with this one is maybe I could write the same base here, almost, 2 squared of x. Let's try using the change of base formula, okay? And we'll make him log base 10, okay? So the change of base formula, this is what someone was just asking me today, or maybe I'll use natural logs since these say logs. The change of base formula says that if you have the log base b of a, you can write that as the natural log of a divided by the natural log of b, or the log of a divided by the log of b. You can change to any base you want and put the log of this over the log of that. So maybe that'll help here. Let me try that. So if I rewrote this first one as the natural log of x divided by the natural log of 2, and then how would we rewrite the second one? Natural log of x divided by, well, we could write the natural log of 4, but I'm going to write it as the natural log of 2 squared. This is a tricky one. But I think this is going to work. The most powerful of the log laws is log law number 3, which has to do with taking this 2, this exponent, and bringing it down here. Okay? So I think that's going to be my next move. Natural log of x over the natural log of 2 plus the natural log of x over 2 natural log of 2. Okay. And those are two fractions. Can I add the fractions? What do I need? Need a common denominator. Can I get a common denominator? Well, sure. All I have to do is take this fraction and multiply by 2 over 2. So let's see how this works. I get something over 2 natural log of 2, right? Once they have the same denominator, I can add them, and I get 2 natural log of x plus the natural log of x. All right? And now I'll use that log law again. Put that 2 up here. Oh, I don't even have to do that. What is 2y plus y? 3y. So 2 natural log of x plus the natural log of x, that's 3 natural log of x over 2 natural log of 2. And now I'll use that powerful law to put these back up here. And so I get the natural log of x cubed over the natural log of 2 squared. That's the natural log of x cubed over the natural log of 4. And now, using the change of base formula backwards, I can finish and say that this is the log base 4 of x cubed. That last step was noticing, see this? That looks like that. It's the natural log of an a over the natural log of a b. Therefore, I ought to be able to write it as 1 logarithm. Okay, so they took the 3/2 out front, and wow. That's tough. I decided to do it this way. They ended up with this. It shows you that there's something kind of weird about these exercises. On an exam, I'd be hesitant to ask a question like this one because, first of all, there's more than one answer, right? On a homework, the nice thing is I get you guys using lots of log laws, and that's going to help us as we get into this equation solving, which is where we want to go with this. Okay. I think we're nearing the end here, guys. If you want to pass up whatever homework...